Okay. So, ideas here. How should we go about doing something like this? Yeah, Hunter, what do you say? Find the average? Okay, so what do you mean, find the average of what?
Just like add the x's and add the y's and divide by 2.
So divide by 2. So we want to put 2 benches in, though, so it divides it into 3 equal sections. Okay, so we want to put in 2 benches. So you have like the right idea there, but if you only divide it in 2, that means you're going to find the midpoint. So yeah, we want to divide it by 3. Use a straight edge here to help me draw my straight line. Okay. So let's see here. Okay, so yeah, so let's take a look. So, and specifically, we want to find the coordinates of the second position of a bench. So that means we don't want to find the first bench, we want to find the second bench. So let's see here. So we have to find like the change in the x's then, right? So we go from an x-coordinate of 0 to an x-coordinate of 4. Okay? So the x change, the run, I guess we'll say here, is a change of 4. Plus 4. All right? Okay? And then the rise, what's that here, Hunter?
8.
Yeah, it's a rise of 8. And again, be careful here, folks. We're counting by 2s. Each of these lines is, right, it's like 2, 4, 6, 8. And so make sure when you count there, you're okay. So up 1, 2, 3, 4, 5, 6, 7, 8 to the point there. So that's right. So we're going to go up, okay, 8. Okay. But of course, yes, we don't want to go the full distance. We only going to want to go, what fraction again? 2/3. That's right. Yeah, we want to go 2/3 in, right? 1/3 would take us to the first bench. We want to go to the second bench, so we want to go 2/3 of the way there. There you go. So that means this total distance of 4. If I want to find 2/3 of that, what should I do? Yeah. So 4 for the x times 2/3 is going to be 8/3. It looks like. Right? 4 times 2/3 is 8/3, or if you have your calculators there, it's like 2.6 repeating. Is that right? Did I do that math right? 3 and 3. Yes. Okay. And then for the y-coordinate, or not for the y-coordinate, like the change in the y. The change in the y, we're going to go, let's see, it's a total of 8, but we want to go 2/3 of that, so we'll do 8 times 2/3 again. And so that's going to be 16/3, which is 5.3 repeating. Oh, yeah, I'm sorry. Actually, let me do it this way. Okay. So instead of going right the total amount of 4, we're going to go really right 2.6. Okay, and then instead of going up the full distance of 8, we only want to go up the distance of 5.3. So with that being said, what's going to be the coordinate of that second bench? A, B, C, or D here. Which one is it going to be? I could also say right 8/3 and then up 16/3 too. So yeah, which one does our answer have to be here then? If we start here, okay, to get to that second bench, we're going to go right 2.6, which is right 8/3. So what should our new x-coordinate be then? From 0, we're going to go right 2/3. So what should our new x-coordinate be? Or not right 2/3, right 8/3. So if we start at 0, what's our new x-coordinate? What's that? Yeah, 8/3. So what's got to be the answer here, Maria? Yeah, it's got to be D. D is the only possible one. Okay. All right. Now, if you guys remember, we did this another way, a different way, a second way. Does anyone remember what's another way we did this? I'll give you a hint. It involves using a ruler, Stephanie.
Does this really measure and then divide that measure by 3?
Yep, exactly right. So in this case, we also could have taken the measure here, which is about 3 centimeters. Would anyone else like a ruler, by the way? Straight edges? All right, I'll just pass them around. Might as well, right? 1, 2, 3. triangle in there?
No, this is an operator special.
Oh, okay. Okay, you're welcome. All right, so we use the ruler, right? We measure the full distance there, and it's just about 3 centimeters. Okay. So this is an alternative method here. It's just about 3 centimeters. And then Stephanie, you said to divide that by 3.
I can't remember, like, you do something, or what is it, something over 5. Like, what you do that?
Oh, I see what you're saying. That's if we wanted to partition it into like 2 parts on one side, 3 parts on the other side. In this case, we want to break it into 3 equal sections. So in that case, we want to divide it by 3, so we divide it into 3 equal sections. So you're right, divide it by 3. So that gives us 1 centimeter here. It's pretty easy math. But then, how many of those sections do we want to go in? If we go in 1 centimeter, are we at the bench that we want? No. What bench do we want? The second one. So how many centimeters do we have to go in? 2 centimeters. That's right. So we're going to go into right about here, and there's about 2 centimeters. So there's where our bench is. Now the problem with this method, if we measure that, right? What's the problem that we run into here? With the location of this point, what's the problem with this location? If we want to know what the coordinates are, what's going to be the problem here? Can anyone tell me what those coordinates are? Mason?
It's not on a point.
Yeah, it's not really on a grid line. And so we're kind of like stuck a bit. But we can like figure it out. Since this question is multiple choice. For example, if we look at A, is it possible that this is the coordinate for this point? Why not?
Because it's not more than 2.
Yeah, it's not more than 2, and look at the y coordinate. It's negative. Yeah, so that's not possible. All right, let's look at B. Is B possible? It's exactly 2, and that's not exactly 2, so no. And so that's down between these 2 points, which can be kind of tricky, admittedly, here, if we take a look, right? Because it's like hard to tell. It's like, that could be 10/3, right? But maybe not, because 10/3 is a little bit over 3. Right, if I use my calculator here, 10/3, 10 divided by 3, is like 3.3. And that does not look over halfway between 2 and 4. That looks under halfway between 2 and 4. So it's not C. And so the answer, again, we kind of are left with D. 8 divided by 3 is about 2.6666. And that does look under 3, right? That looks just a bit under 3 for the x-coordinate there. So you can kind of like logic it out, so to speak, without having to find the exact answer. But what Hunter said to do would work exactly. So, yes. Those are. Say it one more time, sorry? Oh, I see what you're saying. Well, that's kind of like harder to calculate, but we could. I mean, so again, you're okay with the fact we started at a 0 x-coordinate and we added 8/3 to that, so it gets us a x-coordinate of 8/3. Like, you're good with that? How we got that x-coordinate? Yep. So that's an easier one because we start at 0 and go to the right 8/3. Then the y-coordinate though starts at -5, and to that -5 we're going to add the 5/3. Well, what's -5 plus 5? Or not 5/3. What's -5 plus 5.3 repeating is just going to be that 0.3 repeating, so it's going to be 1/3, right? And so then we're left with the y-coordinate 1/3, and sure enough, that's the matching y-coordinate. Okay. So the real reason why I didn't do it for the y-coordinate is because the only x-coordinate that was 8/3 was D, so I was like, oh, well, that has to be the answer, so we just stopped from there. Okay. So does that answer your question? Okay. Other questions on that one? All right, you'll see another one when I give you guys your assignment here too. So let's get down to number 5 then. All right. So number 5, we're told that triangle STR has vertices -4, 2, -3, -3, and -1, 1. Suppose the triangle is 1, reflective of the x-axis, and 2, dilated by a scale factor of 2 with the center of dilation at the origin. What are the new coordinates of the image S', T', R'? So, ideas here. What could we maybe use to help us do this one? Or what can we do to help us do this one? Any ideas? What kind of strategies could we use here? If I want to take STR, I want to reflect it over the x-axis and then dilate it by a scale factor of 2, and I want to find the new coordinates of the image s prime prime, t prime prime, r prime prime. So any ideas here? How could we like maybe do this? What can we use? What might be something we can help that can help us do this? What do you say, Hunter?
You like negative x. I mean negative x y is equal to x negative y.
Ah, okay. So you want to use coordinate notation? Yeah. So absolutely here. So we can take our normal xy's and then we'll reflect, and the reflection over the x-axis is x comma negative y. Very good, Hunter. Exactly right. And then what's going to be the next one? If we want to then dilate that by 2, what should be our next kind of thing we do? Yeah, so we'll do 2x comma 2y. So you can remember those transformations. How did you remember that x and negative y was the transformation for reflection there? You just like remembered it, or?
Yeah, I just memorized it.
Okay, that's okay. Because when you reflect over the x-axis, do the x-coordinates change? Yeah, the x-coordinates stay the same, and the y-coordinates are just the opposite. If it's above the y-axis, it flips down to the bottom. If it's below the y-axis, it flips up. Below the x-axis, it flips up to the top. So yeah, so that's it. And so at this point, we can just write the coordinates we want to in there: -4, 2, -3, -3, and -1, 1, and then just do the transformations there. Okay, so we end up with -4 comma -2, and then multiply those both by 2, we get -8 comma -4, and that would be s prime prime. Okay. Is it necessary for me to do all the points? Yeah, it's not, is it? Because the very first point we get, s prime prime, there's only one answer that's got -8, -4, and that's C. So it's got to be C. It's got to be C. Okay. Anyone have an idea for a different strategy we could utilize there besides like writing out those coordinate notations? I know some of you guys maybe don't have those memorized, and you don't necessarily need to. What else could we do there? What other ideas could we do besides remembering those coordinate notations? What else could we do here? Yeah? Yes, graph paper! Okay, so we can use some graph paper here. We'll take a look at that too. Just make sure we're comfortable with that. Oh, I have enough. We'll see here. Let's just cut these in half. Let's use those smaller sheets. Over that way. Graph here. Pass one down to Keegan, too. Thank you, Beth. Okay. So, let's try actually graphing this and do it that way too. Just make sure we're okay with that. Okay, because some of us maybe don't remember those. Some of us maybe don't remember, right, those coordinate notations, and that's okay. Okay, so you plot the points. -4, 2, and that's S, and then -3, -3, T, and then R is -1, 1. Okay. Excuse me. So now, if we want to reflect this over the x-axis there, okay, how are we going to go about doing that? Can you describe it there for us, Melissa? How are we going to do it? For example, if I want to reflect S, where is it going to end up? How do I know how to reflect over the x-axis? What do we do?
Well, you have to go to the x-axis, so the x-coordinate would remain the same.
Okay.
You would, since that's 2 up, you would go 2 down.
Yeah, exactly right. If it's 2 above our line of reflection, it's got to end up then 2 below. So this is where this point would be. And we're going to call this S prime, right, it's been transformed. And then T is 3 below, so it'll go 3 above, T prime. And then R is 1 above, so it's going to go 1 below, staying the same coordinate. And so there's kind of like our new reflected triangle there. Looks like a little crooked Star of David. Okay, very good. And then if we want to dilate that by a scale factor of 2, all right. So Patrick, how can we dilate that by a scale factor of 2? What are we going to do?
You're going to multiply each coordinate by 2.
Beautiful, exactly right. So T prime, its current coordinates are what? Negative 3, 3. So it will become what, Patrick?
Negative 6, 6.
Yeah, negative 6, 6. So negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. So there's T, and we'll call that T prime prime, right? Because it's been transformed. So negative 6, 6. And again, at this point, once we get that one coordinate, I can just look at my multiple choice here and see, T prime prime is negative 6, 6 only in letter C, and so C's got to be the answer. If there's multiple ones that have negative 6, 6 for T prime prime, then you do obviously some more, right? We could do the same thing to R prime prime, multiply it by 2, and it'll become negative 2, 2, or negative 2, I mean. So there's the R prime prime, and then S prime prime would be out 8, and then down 4 there, so there would be S prime prime. Okay. So there it is, dilated out. All right. So multiple ways to do that there. Whatever you get stuck with, or whatever you feel like you can do. Questions on that one? We're okay on that? All right. Let's scoot on here then. Number 10. Okay. So number 10, again, talking about an image under a dilation, so that is similarity, okay, using scale factor and stuff like that. All right. So let's see here. So we're given triangle LMN in the graph, so this is like the original, and triangle L prime, M prime, N prime is the image of this triangle we're given for a dilation with center at 0, 0. If M prime, N prime is 6, what are the coordinates of L prime? Okay, so M prime, N prime is 6. What does that correspond to here in the original triangle, Julia? M prime, N prime, that's a length of 6. What does that correspond to here in our original triangle? What does it match to? This is M prime, N prime is in the image. Yeah, Mn. What's the length of Mn? I was going to say, yeah, you probably want to use your paper, not mine.
4.
Yeah, 4. And so then, Julia, what's going to be the scale factor? What's going to be the number that we have to kind of take that 4, multiply it by to give us 6? How do we find scale factor again? Do you remember? I think I left it. So close. It's going to be the image divided by the original. So not 6 minus 4. Yeah, divide by 4, yeah. So 6 over 4. That's the scale factor, which simplifies to 3 over 2. Okay, scale factor equals 3 over 2 there. All right, great. So that gives us a scale factor. So that's going to help us then because we want to find the coordinates of L prime. Well, Julia, what are the coordinates of L?
-4, -5.
Yeah. And so then to find the coordinates of L prime, its image under the dilation, what would we do to those coordinates?
Multiply them by 3.
That's it. Yeah, exactly right. Exactly right. So -4 times 3 halves is -6. And -5 times 3 halves is -15 halves, which is -7.5. Aha, and you'll see here that B and C, they both had the x-coordinate of -6, so we had to also find the y-coordinate too, -7.5. So it's got to be C. Okay, so that's it. Questions on anything there? No questions on that? Again, it's just making that scale factor, find the scale factor there, okay, for the dilation. All right, let's skip on here. Moving on. Okay. Excuse me. Number 11 then, the grid in here, talking about dilation, so again, dealing with similarity. All right, and this one it says to find the x-coordinate, very important here, find the x-coordinate of n prime such that m prime, n prime, that segment, is the dilated image of mn through the origin. Okay. So we have m prime's location. Okay, so let's see here. So, Mary, what are the coordinates of m prime here? Bless you. Oh, sorry. Yeah, it's hard to find. We're on number 11. Can you find it? Okay, there you go. All right, so what are the coordinates of m prime there in the picture there, Mary?
M prime is -2, -3.
Uh-huh, that's right. And what are the coordinates of just m?
-4, -6.
Yep, -4, -6. So what does it look like our scale factor is here, Mary? What are we multiplying our original by to get that image coordinate of m prime there?
1/2.
Yeah, exactly right. Yeah, we're taking that -4, multiplying by 1/2 to get us -2. We're taking that -6, multiplying by 1/2 to get -3. If we weren't sure here, folks, we could take that scale factor. Again, what's the scale factor? It's the image over the original. Okay, just like Adam said back in the warm-up. Okay, it's the image. So give me a coordinate from the image. Well, either the -2 or the -3 doesn't matter. I'll just pick the -2 over that matching coordinate in the image, -4, and it gives us 1/2. So there's the scale factor again, just in case you're like unable to kind of see it. Okay. And so then, Mary, how can we use the scale factor to figure out what the coordinates of, or sorry, how can we use the scale factor to find the x-coordinate of n prime? What do we got to do?
So we find the coordinates of m, which is
Okay.
4, -2.
4, -2, okay. And then what?
And then we multiply that by 1/2.
Great, yep. And so that will leave us with what coordinates?
2, -1.
Yeah, so so 2, -1. 4 times 1/2 gives us the 2, and then -1. Okay. So right there would be n prime. And of course, the answer we put in the grid in here is going to be what, Mary? To answer the question.
X coordinate?
Yes.
That
So-
would be 4.
So, well,
I mean, no, that would be 2.
there you go, exactly right.
That's the wrong one.
No, yeah, I figured as much. Okay, so yeah, 2. Okay, just like that. Don't forget to bubble in the little 2 there. I think it starts at 0, it goes 1, 2, so that's why that's a 2. I know sometimes it's hard to read that there. All right. Questions on any of that? I'm just using your scale factors there. Okay. 12. If I can scoot it up there. Okay. Number 12 then. What's the scale factor? Again, another scale factor question. What's the scale factor for the dilation centered about the origin below that would map triangle PQR to triangle ACB? Okay, so let's see here. So let's go to someone we haven't heard from yet. Nope. All right, so Keegan here. What's the scale factor for this dilation centered about the origin below that would map triangle PQR to triangle ACB? So, let's get some coordinates here.
Yeah.
Give me a P's coordinate. What's the coordinates for P?
-3.
Yeah, it is a -3. These
The 1.5.
Yep, and 1.5. Very good. Okay, and then P corresponds to what in the other triangle? A. So what are those coordinates?
-2, 1.
-2, 1. Good. Now, we got to find the scale factor, right? Scale factor is equal to what over what again?
I forgot.
So image over original.
Okay, yeah. Image over pre-image, right?
Yep, image over pre-image, if you want to say it that way. Absolutely. And so in this case, with those points you just identified, which one's the image and which one's the original?
PQR.
Is the, yes. How are you able to tell that?
Okay, it says PQR 2.
Exactly right. Very good. Yep, it's in the directions here, folks. We're mapping PQR to ACB. So we're transferring PQR to ACB. So PQR is the original and ACB is the image. Good. And so that means we're going to put what number in the numerator there for the image?
-3.
So you just said PQR was the original.
-2.
-2, or what other number could you put in there?
1.
A 1. So you picked -2. I like that actually one better, and you'll see, I think, why in a second here. So, okay, and then what's the matching original?
-3.
So it's -2 over -3, so it's 2/3. There's the scale factor, and again, you just write that in 2, the slash, and the 3. Yes, the slash is part of the answer. You grid in the 2, you grid in the little slash there, you grid in the 3. Okay, voila. Okay, please do not give me 0.6. 0.6 is a rounded answer. 2/3 is the precise answer. Okay. Questions on any of that? We're all good there? All right. And let's move on to the last one here, which is the proof. The P word we have not heard in a long time. Okay, oof, there it is, number 15. I had trouble finding it. There it is. All right. So let's kind of take this all in here because it's a free response question, so these take a little more, concentration. All right, so 15 says, a graphic designer has been hired to design a logo for a company. The logo is to contain 2 similar triangles as shown below. Okay, so there it is. Note the figure's not drawn to scale. Mark the diagram with the givens and prove that triangle SRT is similar to triangle URV. So SRT is similar to URV. Write a 2-column or paragraph proof. All right, so the only given that we have is that UV is parallel to ST. Okay, so we're supposed to mark our picture with that. So how do we mark something like that? Michael, how do you mark that UV is parallel to ST? How do we mark that on our picture there?
Arrows.
Yes, exactly right. There's one arrow there and one arrow there. Perfect. Okay, so that right there, that's a point. All right, because it just says to write that, and then we're also supposed to write a proof. So let's go ahead and get that set up here. Okay, we'll have our statements over here, and then our reasons over here. Okay, and let's go to, so Drew, first step in a proof. The given UV is parallel to ST. Okay, and the reason is given. Oof. And now we have to try and prove these 2 triangles similar. So what are some ways that we use to prove triangles similar in the past? We maybe didn't do a 2-column proof, but we still used like some similarity shortcuts, I guess I'll say, right? Does anyone remember any of those similarity shortcuts? So what's a similarity shortcut? Yeah. What's that?
Like a ratio?
So, okay, we use ratio. So like we had to check like all, so for example, we had like side, side, side. If all 3 sides of one triangle were proportional to all 3 sides of the other triangle, that means the triangles are similar. So side, side, side was one of them. What's another triangle similarity that we have? What else? Side angle side was one of them. Yep, and there's one more. Angle side angle, it's included in this one. So the third one, yep, Mary? Angle angle. Angle side angle is basically like included in angle angle because angle side angle has 2 angles, and so we don't even need the side, just 2 angles. So exactly right. So what does it look like given these 2 parallel sides here? Does it look like we're going to be able to use side, 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 for example? Do we have enough information to use side, side, side? If you look here, I have this side of the smaller triangle, I have this side of the smaller triangle, but I do not have this side. So can we use side, side, side here? What do we say? Can we use side, side, side? Yeah, no, we do not have information. Side, side, side can't use it. All right. What about side, angle, side? Do I have enough information there? I've got one pair of corresponding sides. Do I have another pair of corresponding sides? Yeah, no, we don't. So if I can't use side, 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 and I can't use side, angle, side, we have to go to angle, angle. But I don't know any angles here. Or do we, Mary?
Since the 2 lines are parallel, you can use corresponding.
Okay, so can you name me a pair of corresponding angles, please? So angle RUV, and then angle S. Yes, they're going to be congruent. Anything else?
Angle RBU,
Mhm.
angle RTS,
Yep. And then actually, there's one more congruence here we can show.
angle R.
Yeah, it's. So we can just say it's congruent to itself, right? And so let's just do that. Let's just use that. So we'll say that angle R is congruent to angle R by the reflexive property, right? That's what that means.
Look it up.
I'm sorry, yes. Thank you for saying something. Okay, and then we'll say angle RUV is congruent to angle RST, and that's, again, exactly right. They're corresponding angles. I'm just going to use the angle symbol. Corresponding angles are congruent. Okay. And we've shown two angles congruent, so triangle SRT is similar to triangle URV by angle. So that's the proof. It's real simple. Okay? Using those parallel sides there. All right. Questions on any of that? So, letter B here says, given that triangle SRT is similar to triangle URV, find US. And so what I want you to do then is go ahead and do that. All right, I'm going to go run and grab the homework out of the copy room real quick, but go ahead and do that. So X is the length there, US. I'll give you a hint, it's very similar to the problem that we did in the warm-up. Okay, so go ahead and try and find US given that information. Now,